All right, hi there, class. Second video. Please try to get through this one so you have the tools necessary for next Tuesday's class. Next Tuesday, I think going to be the 19th of January. Do some math. Okay, a couple things we're going to run through today. First, going back and forth to Rhino. Obviously, you learned a bit on Thursday that Revit isn't the best when it comes to conceptual massing. Early parts of the design process have often been identified as the biggest flaw that Revit has, right? And a big part of why we don't teach it earlier in the curriculum, because it requires quite a bit of conscientiousness about what you're trying to make when you go to model it. It's not a tool that's necessarily developed or was even maintained in order to do form finding. So really, it's important to understand how to move back and forth between Revit and Rhino, which admittedly is not the easiest thing to do, but does provide you some. Well, what I show you today will provide you some kind of linkage that you can start to use to go back and forth. Really, the move to Revit happens once you've started to identify what form you really want to run with for your project. So we're going to start in Rhino briefly, just to put together a little bit of line work that we can use to move over, and I'll demonstrate a little bit about what happens when you translate objects back and forth. So I've just gone to the curve dialog here, and I'm just going to do a curve interpolate from interpolate points. I'm going to do just a similar profile to Shanghai Tower that we did the other night. I'll turn my O snaps on. Moving quickly through this because I'm assuming y'all know this. Join those two curves here in the elevation. I'm going to copy that curve, move it up in space, select the one that's up high and rotate it. So I'm just going to make the profile of the Shanghai Tower and scale it. And loft between the two. I need to adjust my loft curves just by dragging these arrows. You can identify the way we want the loft to work. That's not it either. Let's move them over here. There we go. Turn on the shaded view so we can see what we're doing. And lastly, I'm just going to select that loft and hit cap to cap it. So what I've got in the drawing here is one solid model of the Shanghai Tower form, and then two curves. So first thing I'm going to do is select just the solid and hit File, Export Selected, and I'm going to save a test of DWG. You're going to want to go into your options here for the export. And 2004 lines is the most recent version you can do, and go to Edit Schemes. By default, you're going to see that Export Surfaces is linked to, is defined by curves. So you're not going to get any surfaces if this stays as curves. So you want to flip this over to solids so that you're getting vector-based solids that are coming in. Meshes are always going to be meshes, and we're going to see a little bit today, going back and forth between these two, the differences between solids and meshes. Meshes are very difficult to edit really in any piece of software, but in particular in Rhino. Rhino really likes to work with what are called IGES or NURBS solids. And really Revit doesn't necessarily work with those NURBS surfaces, and that's why we have so many difficulties. Now with Dynamo is bringing some NURBS functionality in, and as we get deeper into the semester, we'll show that. So I'm switching this export surfaces over to solids, and I'll hit save and close. These are just the export settings found under the options button here when I go to export my solid. And I just call it test, say okay. I'm also going to select just the two curves and hit File, Export Selected, and save those two as test2.dwg. I've already saved those settings to make sure they're going to solids. That we're not exporting any solids here anyway. So that's all I'm going to do here in Rhino. Bounce back over to Revit and just going to open up an architectural template. And just to quickly show you what happens, I'm going to go to Insert and Import CAD and select that first solids file. It might be important to register where you're placing it. So here on level 1, oriented to the view, it's going to try to auto-detect the units as it comes in, but you can also come in here and define them. So you're going to see quite a few errors with these things as they come in. Again, it doesn't like this kind of object. I'm just going to the View tab and making a new view. And you can see actually it didn't even import all of the geometry for this one, just the stuff that it could. So the issue here now is that this object is really useless. It can't do anything other than just visualize it inside of the model. It's simply a surface, and if I explode it, it basically goes away. It's not able to salvage any of the geometry. So this is just to highlight what some of the issues are when you try to move back and forth. The two pieces of software just speak completely different languages. So now I'll try creating, going in here and using the insert to import a CAD file and just the two curves. You can see those come in much more cleanly. But again, when I select them and hit explode, you can see it flattens everything. It kind of deletes parts of the curves that it can't resolve using Revit geometry, so it's not nearly as useful. But what it is useful for, and if I come in here to level 1, you can see these two. You can see these two curves, and really now you can go to your massing in site and do an in-place mass. And what I would recommend doing is using the spline through points tool, and simply tracing the curves that you're bringing in from Rhino. Obviously not ideal, but part of what is required until these two pieces of software start talking better to one another. Going to snap to the end, make sure I'm snapping to those two. Now I can select these two. I'm going to hold Control key in order to get both of them and hit Create Form, and I'm able to extrude that piece. Oops, I did it as a flat geometry, sorry. Edit in place. Do a 3D, go to the 3D view so we can see what's going on here. And we're back with our mass, much like how we had from last time. So again, not the most ideal kind of interface. Actually, going the other direction, Rhino has always tended to be much more flexible. So just to demonstrate that briefly, I'm going to go to View and User Interface and pop back out to the open screen here. I'm just going to select the sample architectural project. Come over here to a regular 3D view, select the 3D view, and I'm just going to export. By default, it was set to it was showing us a drawing. If you're on a drawing and you go to export, you're going to get a drawing. So here I'm going to go to Export in CAD and export a DWG file. Again, we need to adjust the settings. This is a little bit harder to find. I'm using the ... options button right here for changing the export settings. And so there's a whole series of different export settings for DWGs. The key one here is again going to solids. By default, it's going to be set to polymesh. We're going to want to flip that over to ACES solids again, much like we did going the other direction. I'm going to say OK, next, and just save this file out. I'm going to save that way, and rather than waiting for that, I'm just going to import an earlier version of it. So back in Rhino here, I'm going to go to Import, select that file, and hit Open. All of the default settings here should be okay as long as your units are the same. You see it does still give me some errors, and I'll show you what those are, of invalid poly surfaces. Though for the most part things will come in pretty cleanly. Takes a second here with all the geometry that it needs to process. So what you see, and I'll make this full screen, is the topography is made out of a mesh, which again is difficult to kind of manage. But there are curves in here that are helping, that might help if you were actually trying to draw some topo, which is actually what we're going to do for the rest of the day. But what you see here is that the Revit geometry actually comes in really cleanly. It's all block instances, so it's references. Here are those errors. So there was something in this wall type that resulted in bad surfaces that weren't able to be trimmed. So they were being trimmed by the roof. For some reason, the Rhino piece, Rhino's translator didn't like them. But almost always, anything that you bring in, just as a general wall type, window types, is going to come in relatively cleanly into Rhino, and it's pretty easy to actually use the layer structure as it's coming in from Revit to control it and maybe define materials if you wanted to do renderings. I think the key use here in bringing stuff back into Rhino is for diagramming. So doing those early diagrams that explain the kind of organizational strategy for the project, those sorts of things. So you can sort of distill down the stuff that you've got in Revit that would otherwise be really busy into something that would be useful in a diagram set, and you'd have really accurate kind of simple solids that are here and can be used. Again, if you really wanted to start digging into these, you basically need to go in and explode all of them. You can see that just that wall resulted in 20 surfaces. I'm going to explode it, select the part that's bad, deselect the part that's bad, and then hit join to join it back together. Now I can select that bad piece, and I've got a cleaner wall now. I can hit hide, and there's the resulting piece. So I was able to just get rid of, again here, some of these bad surfaces by exploding the block, which is coming in from Revit, deleting the bad surface, and then rejoining the wall pieces. This one's a little different. Looks like it's got a little edge on it. Anyway, that would be the technique that you'd use. Okay, so back into Revit, the second part of what I want to do today, and I'm just going to close this file. Close this example, pop back out to the start screen, and again I'm just going to start a new architecture template. Second thing I want to do today is go through the way in which you would bring topography in. First, we're going to talk about how to do it with an image. So if I'm working in Charlotte-Mecklenburg, the city has a great navigation site for getting property boundaries called Polaris. So just Googled Charlotte Polaris 3G, brings up a map of the city. I'm going to put in 300 West 3rd Street, downtown. It's giving me a couple of options. This is what I want, not West 23rd. So here we are actually across the street from Romare Bearden Park. So I'm just kind of panning around here to center the park. Up here in the top right is where you can turn on the topography lines. I'm going to hit the topo. This brings up the topo. These are 2-foot topography lines moving across the site. In this case, if our site is Romare Bearden. Over here on the left side, I can hit layers and labels, and I can turn on, in particular, lot dimensions, which will be useful for making sure that everything is set. And then I also want to come down here. Actually, that's it. I think I'll just leave the lot lines on and use that to help scale it. So even though I put in 300 West 3rd, it's because there was a building address there. Really what I'm interested in is Romare Bearden here. So we're going to use these edge lines to actually help us define the scale of the drawing. And so what I want to do is actually export this and get it out. There's two ways to do it. If you're wanting a PDF, you can hit this little print button here in the interface. The thing is that it generates a PDF, and we don't actually want a PDF. We need just a regular image. I'm going to use Windows screenshot tool, which is called the snipping tool. This brings it up, and I'm just going to select this area around the park, including the entire park, and hit save. I'm just going to save it as a JPEG. It works as a PNG just the same. Save that. Close out of here. Okay, so back in Revit, again, I'm going to insert here, but this time I'm inserting an image, capture.jpg. So this is in the Insert tab, Insert Image. You can see I can kind of come in here and place it. And then what I want to do is I'm going to use the Align Dimension tool here under the Modify tab to control the size of to scale the size of the image to be appropriate for what I'm doing. So let's find something that's relatively large and relatively easy to control. So I'm going to do this 395 foot one here. Okay, so we've got the image in here, and I've copied and pasted into the site view. So from level 1, I've selected the image and copied it just by hitting Control C. And then I can go to, once I've gone to the site view, I can go to paste and paste align to selected views and select the site view. This is really handy for pasting to lots of different levels as you go. So once I've got the image here that I'm going to use to trace the topography set into the site view over here in the project browser, I need to scale it. So I'm going to select that image and go to the scale button up here in the top row. And what I want to do is select one of these edges that I can define. So this one is 395.94. It looks like it goes from this corner here to this corner here. You can see I already scaled mine, but I'm going to adjust it to 395.94. So I'm just clicking twice. The scale will continue to move until you start typing. And then you type in, hit return, and that'll scale the image to match the dimension that you defined there. Once I've got it in here, now what I want to do is actually start making the topography based on this. I have to pop back out here to the Polaris in order to sort of identify what elevation we're at. You can see that there are sporadic notations of the 10-foot markers, which are the solid ones inside of the drawing. So diagonally across the street here, I see a 740, which means this one is a 730 just below it. And I'm going to trace that, follow it down across Poplar, and then into Romare Bearden. So if I assume that this one is 730, I'm going to assume that these go up to the circular one here. That would be 732, 734, 736, 738, so on. And then down towards 720 with this piece that's going across towards Brevard Court. Actually, it looks like if I remember correctly, it's going to be just the opposite of that, now that I say it. So here's the baseball stadium, and I know the park slopes that direction. So I'm going to assume still that this is 730, but these are going down to a lower level, and that these are going up towards 740 on the side nearest Church Street. So so back in Revit, I'm going to go to Topo Surface here and begin placing points. So one thing you need to do before we actually begin doing this is we need to adjust. Since we're going to be drawing so high up in the air, up at the 730 and 740 elevation heights, I'm going to go to my site view, and this is a handy thing to note. Regardless, you can see down here under the properties for that site view are the extents. And under the view range here, by default, it's set to 200 feet. So we're not going to be able to see anything. So if you start clicking with the topo tool and you're not seeing anything, it's because the view is being cropped. So I'm going to change this up to 800 feet and say OK. And that's going to allow me to start to see things here in the site view as I'm making these topos. So now all I'm going to do is just place points along each of the topo lines, and I need to define what height they're at. So again, we're going to start here with the 731. I've put 730 into the green tab across the base here, and I'm going to click through across this line, and you can be more or less accurate as you want in the translation of each of these, and I'm going to take it over to the edge of the sidewalk. Then I'm just going to click up here without finishing. You can see we're here, still in sketch mode here. I'm going to change it over to 732 feet, and then start clicking across on this next elevation line. And so on and so forth. 734. I'm just going to click a little bit bigger than I was before, but you'll probably want to continue doing it with a certain amount of accuracy, especially if you're going to be using the file. So once I've clicked that through and hit the checkbox, now we can take a look in 3D view at what we've created. And you can see it's actually a three-dimensional topography through that part of the site. You'll want to continue kind of drawing all the rest of this. Once we've got it set here, I can come over to the phase. Once we've got that completed for the entire site, I can come over here to phase and hit existing. And then I can select it, or excuse me. Then once I'm back here in massing in site, I can hit graded region, and I can and it's going to give me two options. I can create a new topo surface based on the perimeter points, or I can create a new topo surface exactly like the existing one. I want to make an existing one so that I've got a before and after, and you can see that once I select it, it's going to allow me to pull on this topo and start to edit. Based on the points that I've already created, and it's going to infer sort of relationships. So if I wanted to create a draining area here from the high point, I could start pulling points to create a ditch through the site down through this direction. And then I can hit the checkbox once I'm done. If I turn this over to shaded view, what you're going to see is that now there's basically two topography layers. One, an existing layer that I created, and the other, a new updated one with my piece coming through it. I can select, at any point one of these and come down and temporarily hide it in order to be able to see the new one. So using the sunglasses, I can hit hide element, and now I can see. I had the new one selected at that time. So go through, create the topography for Romare Bearden, and then adjust it to create some adaptations to it. We'll see you on Tuesday. Have a good weekend.